The observable universe holds approximately 2 trillion galaxies. Each of these galaxies, including the Milky Way, consists of hundreds of billions of stars. Since most stars host at least one planet, often more, the total number of exoplanets reaches staggering numbers, likely in the sextillions. Given this immense scale, even if the chances of life emerging on a single planet are incredibly small, the sheer abundance of planets makes the existence of extraterrestrial life highly probable. Yet, despite all of our searching, we haven't found a single undeniable sign of alien life. No radio signals, no extraterrestrial megastructures, no galactic civilizations reaching out, just silence. This contradiction, the high probability of alien life versus our complete lack of evidence, is known as the Fermi Paradox. And today, we'll explore some of the most fascinating and terrifying answers to this cosmic mystery.
Welcome to Cosmic Cat on YouTube.
The Fermi Paradox is named after physicist Enrico Fermi, who in 1950 casually asked his colleagues, "Where are all the aliens?" At the time, scientists were just beginning to understand the scale of the universe, and Fermi realized something profound. If intelligent life is common, then why haven't we seen undeniable proof of its existence? One possibility is that alien civilizations exist, but we just haven't looked in the right way yet. Think of it like fishing in the ocean with a single net. You might just be missing all the fish. Our methods of searching for alien life are still extremely limited. We mainly rely on detecting radio signals or looking for chemical biosignatures in exoplanet atmospheres. But what if aliens communicate using something we don't understand? Maybe they use laser pulses, neutrino beams, or even quantum communication that we have no way of detecting. Another issue is the sheer size of the universe. Radio waves take years to travel between stars. A message sent from an alien world 1,000 light years away wouldn't reach us for 1,000 years, and our response would take just as long. If civilizations are spread far apart and communicating at different timescales, we might simply be missing each other. Additionally, radio waves weaken as they travel across vast distances due to the inverse square law, spreading out and dispersing their energy. This makes detecting distant extraterrestrial signals even more challenging, as any transmissions reaching us might be too faint to distinguish from cosmic background noise. And then there's the possibility that we are the first. The universe is about 13.8 billion years old, but complex life on Earth only emerged in the last few 100 million years. Maybe intelligent civilizations are incredibly rare, and we're just one of the first to evolve. Another possibility is that civilizations don't last long enough to communicate. This idea is known as the GreatFilter, the idea that there is some kind of barrier preventing life from reaching the stars. This barrier could be the difficulty of evolving complex life in the first place. Life must first emerge from non-living chemistry, a process known as abiogenesis, which we still don't fully understand. Even if simple life forms arise, transitioning from single-celled to multicellular organisms requires cooperation and specialization, which may be rare. The development of intelligence is even less guaranteed. Many species thrive without it for millions of years. Long-term survival is another challenge, as natural disasters, climate shifts, or self-destruction through war or environmental collapse could prevent civilizations from advancing. Cosmic threats like supernovae, gamma-ray bursts, and asteroid impacts further reduce the likelihood of long-lasting intelligent life. If any of these steps are incredibly difficult, then intelligent civilizations may be extraordinarily rare, perhaps even unique to Earth. If the GreatFilter is behind us, it implies that the emergence of intelligent life is an exceptionally rare event, and we have already overcome the most formidable obstacle. But if the GreatFilter is ahead of us, it would mean that the biggest challenge to humanity has yet to come, and that most, if not all, advanced societies that came before us have already perished upon encountering it. One of the most chilling explanations is the DarkForestHypothesis. Popularized by Cixin Liu in the three-body problem, it is built upon 3 fundamental axioms. Number 1, survival is the primary goal of all civilizations. Number 2, resources in the universe are finite. And number 3, there is no way to know the true intentions of an alien civilization because of vast differences in biology, culture, technology, and methods of communication. It is impossible to determine whether another civilization is peaceful or hostile. Cixin Liu argues that the logical conclusion of these 3 axioms is that alien life is guaranteed to be hostile. Our Milky Way contains 60 billion potentially habitable planets. Imagine if 1% of these planets undergoes a biogenesis and forms life. That would mean 600 million planets harbor alien life in our galaxy alone. Assuming just 1% of these life forms develop advanced technology capable of communication, that's 6 million civilizations. If even 1% of them detect a signal from Earth, then 60,000 alien societies would be aware of our existence. Some may ignore us, others may send probes to observe or even attempt contact, but some may see us as a threat. To them, a preemptive strike may be the safest option. Even if we pose no danger now, over hundreds or thousands of years, we might advance technologically and start competing for habitable worlds and resources. If just 1% of those 60,000 civilizations reach this conclusion, that means 600 of them would choose to act aggressively. If intelligent life is as widespread as we suspect, then the probability of encountering at least one hostile civilization becomes a near certainty. This is the crux of the dark forest hypothesis. Civilizations that reveal themselves are seen as infantile and naive, like a newborn crying in a forest full of predators. And in such a universe, silence is the only survival strategy. If this is true, then humanity's radio signals, which have been broadcasting into space for decades, could be a beacon calling out into the dark, and we might not like what answers. Of course, there's always the possibility that aliens have already found us.
These small mummified specimens were unveiled at Mexico's first ever UFO hearing yesterday. They're believed to be 700 to 1800 years
Some
old.
believe that UFO sightings, strange signals, and unexplained phenomena could be evidence that extraterrestrials are already observing us, perhaps choosing not to interfere. This idea is called the zoo hypothesis, where aliens deliberately keep us isolated, watching us from a distance as we develop. Another version of this theory is that advanced civilizations are already living among us, but their technology is so far beyond our understanding that we simply can't recognize them. Imagine trying to explain the internet to a bunch of ants. The gap in intelligence could be so vast that we're incapable of perceiving them. The Fermi Paradox forces us to confront some of the most profound and unsettling questions about our existence. Is humanity truly alone? Or is the universe filled with civilizations that remain hidden? Or worse, civilizations that are long gone? If we do one day make contact, will it mark the beginning of a new era for humanity? Or will we wish that we had stayed silent? The answers may be waiting in the vastness of space. The truth, whatever it may be, will redefine our place in the cosmos. If you enjoyed this journey into the unknown, don't forget to like, subscribe, and hit the notification bell for more deep space mysteries. Until next time, keep wondering and keep watching the skies.